Right, welcome to today's stream. What we're going to be looking at today is the Newton-Raphson method. And without further ado, we're going to get it right on into our first question, which is an 8 marker. I'm going to give you 5 minutes to have a go at that one. Right, so let's get right on into this question. Now, what we're going to do to show that this equation has a root alpha in the interval 2 to 3 is we're going to put both 2 and 3 into this formula. Now, a little trick to do is to actually just type in 2 and press execute. And then what you do is you type in answer, and we do that to the power of 4. And then we're going to minus 12 times the answer again to the power of 3 over 2. Let's put that over 2. And then what we're going to do, we're going to plus 7. And we don't want to do it just there. We're just going to make sure it gets to the end, and we do plus 7 there. And we get this answer, and we want to change it into a decimal answer. That gives me minus 10.94. So if we do f of 2, that's going to give us minus 10.94. Now the trick comes when we go back, and we go all the way back up here, and we just type in the number 3. It recalculates everything. We can press the SD button, and we've now got f of 3 without having to type anything else in. So f of 3 is 25.64. And what we see here is we have a sign change. And what that means is at f of 2, we're below the x-axis, and at f of 3, we're above the x-axis. So between them, we must have crossed the x-axis. So therefore, there is a root in the interval 2, 3. Okay, so because 2 was negative, because 3 was positive, there must be a root in between those two values. Now, taking 2.5 as a first approximation to alpha, apply the Newton-Raphson procedure once to find f of x to find a second approximation to alpha. Now, for part B, what we need to be able to do is we need to know the first derivative, because we need that for the Newton-Raphson method. So f dashed of x is equal to times by the power 4x takes 1 off the power, gives me 3. And then I'm going to times by the power 3 over 2 times 12 is 16. Sorry, not 16, 18x to the half. Now, Newton-Raphson method, okay, I'm just going to call it NR, is xn plus 1, the next term is equal to, so that's meant to be an n, is equal to xn minus the function of xn over the derivative of xn, f of xn over the f dashed of xn. So when x, give ourselves a little bit more space. What I'm going to do, I'm just going to zoom out a little bit. Let's zoom in, zoom out, give myself a bit more space. Okay, so when we're doing f dash of 2.5, we're going to put that into this formula. Well, what I'm going to do is I do need f of 2.5. And save myself a little bit of time. I'm just going to go back up and find f of 2.5 because I do need that. So type in 2.5 at this stage, and I get minus 1.37166490 here. And then I can do f dash of 2.5. And then I'm going to just type that all into the calculator again. I've already worked it out. It's 34.03900106. So if I put 2.5 into here, so do 4 times 2.5 cubed minus 18 times 2.5 square rooted, I get this answer. So therefore, as x1 was equal to 2.5, x2 will be equal to the previous value, 2.5, minus the function of x. So that gives me 1.37, and it was actually minus 1.37 there. Sorry, look, there's the minus. Over 34.039. And you put all the places in. And that gives me 2.5402. So that gives me my answer. And I've got to give it to 2 decimal places, so therefore alpha is equal to 2.54. Now we want to show that our answer gives the correct answer to 2 decimal places. So therefore what we do is, if we do f of 2.545, which is the lower bound, no, it's actually the upper bound, sorry, which is the upper bound of this, we can calculate that, and again we just go back here, And we save ourselves some time, so we're going to put 2.545 into here, press execute, and we get the answer of 0.231 out, and so on. And then we can do the same. I'm not going to go back and do it because I've already worked it out. 2.535. So this is the lower bound of this. So if you think about it, it's the next decimal place 5 above and 5 below, and therefore that will show us we're accurate to this degree of accuracy if the sign changes. And what happens is we get minus 0.13739 out here. So therefore, as there is a sign change, as there's a root, this root is correct 2 decimal places. Is correct to D P. And there you have it. So that's our first question done. So moving to our next question, just get that on screen. Let's just zoom in a bit for you so you can see it more easily. Just move that across. I'm just going to zoom out one. Okay, there we go. So we're going to have another, let me have a think about it. How long did it take me to go through? It did take me just about 5 minutes. So let's give you 5 minutes to do that. Off you go. Right, let's get into this part of the question. So we've got to show, it's the same question, more Newton-Raphson. We've got to show the equation f of x equals 0 has a root alpha in the interval 1.6 to 1.7. So essentially what we're going to do, again, is we're going to work out what f of 1.6, but we've got a new function. So we type in 1.6, remember, press execute, and then we just put an answer everywhere the x is. So press shift, answer x squared, minus, make a fraction, oops, let's undo that, let's delete, there we go, I just went one too many, so minus the fraction. The beauty of it is you get to see it exactly as it should be on here. So we're going to put 3 over the square root of the answer, x, and get up here, and then we're going to take away another fraction, and we get 4 over 3 times shift answer, and that is squared. And we press execute, and we get minus 0.3325. And then remembering what we did last time, let's go back. We want to put 1.7 in, put 1.7 in here, press execute, and you get the answer for that out already calculated. So there we go, 1.7 is 0.1277 and so on. And we've got a sign change, as there is a sign change, there must be a root. Must be a root. Okay, so what we need to do is now apply Newton-Raphson. Again, basically, once you learn the formula, once you learn the method of sign changes, that's it. That's all there is to Newton-Raphson questions, pretty much. So we need to find f dashed of x. So let's do f dashed of x. Differentiate this, we get 2x minus 3 over 2. Actually, it's not going to be minus because this is going to be x to the minus a half. So that, hence, if you do minus 3 times minus a half, we're going to get plus 3 over 2. And then we're going to, that's x to the minus half. Okay, remembering this is the same as 3. Now, actually, what I should have done, this is good. I need to remind you that this is equal to this. A common mistake, actually I'm going to show you in a minute, it's more to do with the second one than the first one, is to actually bring this number up with it by mistake. So we're going to times by minus a half, and we're going to get, when you times a minus by minus, we get a plus, and so on. So take off 1 here, and we get minus 3 over 2. Now a common mistake is to write this as this, okay, and then end up timesing the 3 and the 4. Believe it or not, people do that. Anyway, what you should have is minus 4 over 3 times x to the minus 2 when you write it like this. So times by the minus 2, and we're going to get a plus 8 over 3 x to the minus 3 when we do f dashed of x. So remembering, so we know that x1 is equal to 1.6. So therefore x2 will equal 1.6 minus f of 1.6 over f dashed of 1.6. And I'll put in the intermediate values for you. So I'll just give myself a little more space. So therefore x2 will equal 1.6 minus, when I did f of 1.6, actually we did it earlier, didn't we? Minus 0.3325, and all the other numbers, make sure they're all put in here. And then we put f dashed of 1.6. When I calculated that previously, I got 4.59, it looks like 2, and so on. And calculate that all out, I get 1.672, and we've got to give our answer to 3 decimal places. So therefore, alpha will equal 1.67. Actually, I'll write the extra places in so you can see me rounding it, and we can see that gives me alpha equals 1.672. Right, just one more question just to check you've got that sorted. So here's our next question. Okay, again, give you 5 minutes to do that. I won't labour over the answer so much. I'll just go through the answer quickly so you can check your answer. Anyway, 5 minutes to do this last question. Sorry about that, just missed the end of that. So what we're going to do is we're going to just... The only real root to the equation lies with interval -2, -1. Taking -1.5 as the first approximation, apply the Newton-Raphson procedure once to find the second approximation. So if we apply the Newton-Raphson, we've got to find f dashed of x. So f dashed of x comes out to be 2x minus 3 over x squared. Then we want to find f dash of -1.5. because that's our first approximation. And then we're going to get that is going to be 2 times -1.5 minus 3 over -1.5 squared. And we get, when we calculated that, we get -4.3 recurring comes out of the calculator. And f of -1.5 comes out to be -0.75. So using Newton-Raphson, we know that x1 is equal to -1.5. x2 will equal -1.5 minus -0.75 f of x. F of x1. Okay, so we're going to get 0.75 here over f dash of x1, which comes out as -4.3 recurring. And when we calculated all that, we get -1.67307, and so on. And we want to calculate it to 2 decimal places, so therefore alpha will equal 1.67, -1.67 even. Okay, show that our answer to part A gives alpha correct to 2 decimal places. Now what we need to do, remember, we need to look at the upper bound and the lower bound of this. So we go to the next place and go 5 up and 5 down. So if we do f of -1.675, so that's the upper bound, we're going to get 0.0145. And if we do f of -1.665, the lower bound, we get -0.02957, and so on. So therefore, remember, we have a value down here and a value up here. We must cross in between, so there must be a root in between these two values. So therefore, as there is a sign change, and it's really important you mention the word sign change. Okay, the answer is correct to dp. And there we have it. Okay. So we've now worked out how to do Newton-Raphson. Key things to take away from this is to remember the formula. So it's xn minus f of xn over f dashed of xn. And also to remember that when you want to show that something is in the interval of the 2 points, you take your lower point, put it in, take your upper point, put it in, and if you have a sign change in between them, then you must have a root in between those two values. And it's really important you mention the words sign change to get the full marks on this question. Okay, thank you very much, and we'll be streaming tomorrow, the last in this series, ready for my sets are doing the test this week, and then once they've done all their tests, I will post the revision, the actual papers, and also post video answers to both papers in this notebook, which you can get in the links below. Goodbye.